Good morning, ladies and gentlemen. You may have viewed or will view some trials I've done with ornithopters. Ornithopters which are machines who are flying or try to fly by flapping their wings. I've done two sets of experiments, one which is human powered by myself, and another one which is electronically powered with this machine, powered by a small motor and a set of batteries like these ones or these ones. I want here and now to discuss some of the features I've achieved, some of the developments I've done with these two sets of trials. The first set I want to discuss is the human powered thing, and it will be quite quick because of the human aspect on powering those things. It implies a certain amount of noise, which is quite a pity in fact, and so I cannot comment a lot on those experiments apart from the fact that I achieved 50 kilograms of lift at least, and this is all explained in a trial I've done quite a few times ago, and I won't comment on them further. I want to comment instead on the electronically powered device I've developed since then, and in particular on the some trials you could view on another video that I've just posted. There are two sets of experiments I've done with this, one with a lower power and one with a higher power. The low power set has achieved a lift force of around 0.2 newtons, 20 grams, and you can view them there. This set of experiments works quite well. There is the ornithopter stands on its rubber band and it floats, not moving, and then I put the power on, it lifts, get to its steady state quite quickly, and then I put the power off and it drops again to his no lift position, and then I stop the video. That's quite straight to the result, and there is no further comments to do on that, except the one you may view on the videos I've already posted with the trials or the recording technique. For the higher power there is quite a few things to say. If you look at the video you have here, well, you will see that the ornithopter jumps to a high lift position and then drops again and jumps and drops and jumps. In fact, it oscillates, and it's quite easy to understand if you know that it's on a rubber band and it has some lift that is applied to the ornithopter as soon as it flaps its wings, and so it will oscillate around its stationary position, and then mainly I would stop the power and it stops to flap its wings and then get back to its initial position. Well, that's it mostly. So I have two sets of experiments, one with an oscillation, one without, and the without, so the smaller power experiments get a lift force of around 20 grams, and the higher power experiment get a lift force of around 40 grams. These lift achievements are very great. I'm very happy with that, for the main reason that it is the first time, to my knowledge, that anyone has achieved a lift without any headwind on an electronically powered device. For the human powered thing, I've done it a year and a bit ago, but it's also, to my knowledge, a first, which makes me very happy. I want to add to this achievement one additional thing, which is these two sets of experiments. I want to talk about, on the one hand, the human powered thing with 15 kilograms of lift, and on the other part, the electronically powered setup with 40 grams of lift. allowed me to set the basis of the law that is behind this, and knowing that, I can design a new set of experiments which could allow a true flight, not only a liftoff but a real takeoff with a similar device. And I can design two sets of machines, one with a useful mass of 5 kilograms, around 5 kilograms, which, with a wingspan of 2 meters, and another one with a wingspan of around 10 meters and useful mass of around 150 kilograms. For the last set of experiments with this electronically powered device, I have to specify that this has all been built in my garage without a big mechanical tools and building tools. It's a rough design with the tools I had in my garage, and I could do a lot better if I had a bit more funding. And I have to tell you that if you want to take part of that funding, you could very easily contact me at this mail address, icarus.word@gmail.com, and I would be very happy to answer to your mails and to contact you afterwards. In any case, I thank you for viewing this video and I wish you the best. So, ladies and gentlemen, you just viewed a video about Ornithopter trials. This video is part of a series of 4, where one is about the experiment themselves, with this electronically powered Ornithopter. One video is about the data acquisition itself. One video is about an older experiment with a human-powered Ornithopter we can view here, and another is about the data which have been acquired by those experiments. If you want, you can view one of those 4 videos, which one you choose. And if you are just happy with this video, and leave us know, I'm already happy with that. And in any case, I wish I could show you soon some other results, and while waiting that, I wish you the best. Goodbye.